Hey all, today I'll be explaining you about Venn diagrams. So what is a Venn diagram? Venn diagram is a diagram used to represent the relationship between the sets. In the previous video I have taught you about how to find the union, intersection, subtraction, complement of a set. In this video we will be learning how to represent those relationships between the sets in the form of a Venn diagram. In general, in order to represent a set using a Venn diagram, we need to use a rectangular box, okay, which represents the universal set, and the remaining sets are represented in the form of circles. Okay, so this is the general form. Let me explain you how to find the remaining operations of the set, how to express it in terms of Venn diagram. For that I have taken an example. So let's learn. So in order to find the union of two sets, we need to write down the elements of both the sets together. That is 1, 2, 3 and 5. In order to express it in terms of Venn diagram, you need to write down a rectangular box. Okay, I will give the name, and you need to write U here because it represents the universal set. And these two circles represent the sets A and B. So I am going to write down the elements. See here, I have written the elements 1 and 3 here in the junction of between the two sets because 1 and 3 are common in both the sets, and the remaining element in A is 5. I have written down 5 here and 2 in the set B. The remaining elements of the universal set, excluding the elements A and B, can be written here. That is, there is 4, 6, 7, 8. So in order to represent the union of sets, you need to shade. Okay, here you need to shade both the sets A and B because it contains all the elements of both A and B. This is how we represent the union of two sets. Next, in order to find the intersection between the two sets, you need to write down the common elements in both the sets. So in order to represent it as a Venn diagram, we need to draw a rectangle U and write down the sets A and B. Okay. So while representing the intersection, you need to shade only this part which is common to both the sets. Okay. Next, in order to find the subtraction of A and B, we need to write down only the elements of A which is not in B, that is 5. Okay. In order to represent it as a Venn diagram, you need to shade only this part of A which contains 5. You should not shade 1 and 3 because 1 and 3 is present in set B as well. Okay, you need to shade only this part. Okay. Similarly, in order to find B minus A, it is 2. You need to shade only this part of B which contains the element 2. Okay. Next, how to find the complement of a set. I'll show it for one set A. find the complement of set A, which is represented by A dash, you need to write down all the elements of the universal set excluding the elements of A. So that is 2, 4, 6, 7 and 8. So in order to represent it in Venn diagram, okay, this is your set A, which contains the element 1, 3 and 5. You need to shade, see the remaining elements, you need to shade the part of the universal set excluding the set A. That is, you should not shade this circle part. So this represents A dash. Next we will be learning how to represent the De Morgan's theory, the three laws which I told you in the previous video, using a Venn diagram. Next we will learn how to prove this De Morgan's law with the help of Venn diagram. For the first law, which states that A union B whole dash is equal to A dash intersection B dash, first we will write down the Venn diagram for the LHS, that is A union B the whole dash. Before finding A union B the whole dash, first we need to write down the Venn diagram to represent A union B. Okay. So we need to draw a rectangle box in order to represent the universal set. Then we need to draw circles to represent the set A and B. Okay. So in order to represent A union B, you need to shade this part, both A and B part, to represent A union B. In order to find A union B, the whole dash, again universal set with set A and B. Here, in order to represent A union B the whole dash, you need to shade all the parts of the universal set except these two circles. Okay. So this is how we represent A union B the whole dash. This is our LHS part. Next, RHS. So in order to draw a Venn diagram for A dash intersection B dash, first let us write down the Venn diagram of A dash and B dash. So in order to represent A dash, this will be our universal set, set A and set B. Again, A dash means here we need to shade all the other parts except this circle A, because A dash will contain all the elements of the universal set except the elements of set A. So we need to shade all this part except this set A circle. Similarly for B dash, A and B, here you need to shade all the parts except the circle B. Okay. So this is our B dash. Next, A dash intersection B dash. So in order to represent A dash intersection B dash, you need to write down the set A and B again. See here, in order to represent A dash intersection B dash, you need to take out the common factor. The common factor between these two diagram is only the shaded part of the universal set, because in this one the set A has not been shaded and here set B has not been shaded. Only the common thing that has been shaded is the universal set. So you should not shade within A and B. Okay. So now compare these two. A union B whole dash and A dash intersection B dash. Both of them are same. Okay. Hence first law is proved. Next we shall prove the second one. So in order to find A intersection B the whole dash, let us first write down the Venn diagram for A intersection B. For this again universal set and set A and set B. A intersection B means the common part between A and B. That is, this part has to be shaded. Okay. In order to find A intersection B the whole dash, you need to shade everything except this part. Okay. So this represents our A intersection B the whole dash. Next, in order to represent A dash union B dash, we already have drawn a Venn diagram for A dash and B dash. In order to represent the union of those two, so this is our universal set. See, while writing the union of these two, okay, see here the part B has been shaded, here the part A has been shaded. This intersection part has not been shaded in both of them. So by taking the union, you have to shade this part. Everything except that intersection part. Okay. By comparing these two diagrams, we can say that A intersection B whole dash is equal to A dash union B dash. Okay. Next, in order to prove A dash whole dash is equal to A, first let us write down the Venn diagram which represents set A dash, sorry. So this is our universal set and this is our set A. Okay. In order to represent A dash, we need to shade everything of the universal set except the set A. Okay. This represents A dash. In order to represent A dash the whole dash, you need to shade only the set A and you should not shade the parts of the universal set, which is nothing but set A. Okay. So A dash whole dash is equal to A. This is how we draw Venn diagrams in order to prove De Morgan's law. So here are some important formulas which help you to find out the number of elements in the set, that is number of elements in A union B, which is given by number of elements of A plus number of elements in B. This formula is applicable only if A intersection B is empty, that is there should not be any common elements between A and B, and A and B must be finite sets. Okay. So this is the second formula. N of A union B is N of A plus N of B minus N of A intersection B. This formula holds good if there are common elements between A and B, that is A intersection B is not empty and A and B must be finite sets as well. Suppose they give you 3 sets and ask you to find the number of elements in A union B union C. The formula is N of A plus N of B plus N of C minus N of A intersection B minus N of B intersection C minus N of A intersection C plus N of A intersection B intersection C. Okay, you need to memorize this formula. So let me explain you with the help of an example how to use this formula. Suppose you need to find the number of elements in A union B. Okay, I am going to use this formula because here the sets A and B are finite sets and A intersection B is not empty here because there are elements 2 and 3. So I am going to use this formula. So in order to find the number of elements in A union B, okay, let us write down. See, how many elements are there in A? There are 3 elements. So write down 3. Here also 3 elements. 3 minus number of elements in A intersection B is 2. Okay. This is 6 minus 2, which is 4. So this gives you number of elements in A union B. Let us cross check. Okay. Let us write down the set A union B. So what are the elements in A union B? 1, 2, 3 and 4. You should not repeat the elements as I have already told you in the previous video. 1, 2, 3 and 4. So how many elements are there? There are 4 elements. Isn't it? So number of elements in A union B is 4. Let me give an example how to solve a word problem using the formulas which I taught you now. So here the problem is, in a school there are 20 teachers who teach math or physics. Of these, 12 teach math and 4 teach both physics and math. How many teach physics? So you need to find out the number of teachers who teach only physics. While reading this type of problem, you should be a bit careful because here the word or, okay, this represents the union. That means it represents the union of the teachers who teaches maths and the teachers who teach physics. Okay, and the word and indicate intersection. Okay, that means there are 4 teachers who teach physics as well as math. Now you need to find the number of teachers who teach only physics. Okay, here we are going to use the formula n of A union B is equal to n of A plus n of B minus n of A intersection B, because here the 2 sets which they have given are finite sets and the intersection of the 2 sets is not empty. So how to solve this? Let M denote the set of teachers who teach math, P denote the set of teachers who teach physics. Okay, n of M union P is 20, which is given in the data. Okay, and number of teachers who teach math is 12 and the number of teachers who teach physics as well as math is 4. So now I am going to use this formula. Here I know the value of number of M union P, that is 20, which is equal to number of teachers who teach math is 12. You need to find out the number of teachers who teach physics, and you know the value of n of M intersection P, that is 4. So 20 is equal to 8 plus n of P. So 20 minus 8 is equal to n of P. Therefore, n of P is equal to 12. That means the number of teachers who teach only physics is 12. Hope this video helped you to learn some concepts about Venn diagrams, about how to represent De Morgan's law using Venn diagram, how to use this the formula which I taught you, okay, in the word problems. Thank you.